Okay, today our topic is about maximum, which means absolute maximum, absolute minimum, finding local maximum, local minimum. So let's find them all in one graph, in one question. First of all, what's absolute maximum? Absolute maximum would be the highest number on a graph, the highest value of y on a graph. So in this case here is the highest value, therefore this is called absolute maximum. And the lowest point is called absolute minimum or minimum. So highest value, absolute maximum, lowest value, absolute minimum. The locals are the ones which has a change from increasing to decreasing or from decreasing to increasing. So a local maximum or minimum cannot be at the end points. A and B are the end points. So we have interval of A to B. So a local cannot be at A local cannot be at B. Absolute maximum, absolute minimum can be anywhere between A and B, including A and B. So to find that, the first thing we do is we find the derivative. So whether we know anything or not, we always derive. We factor 3x squared minus 4, and this is 3x minus 2, x plus 2. We make this equal to 0, and the values we get for x equal to 2, x equal to minus 2 are called critical numbers. A critical number is any number which makes the first derivative 0 or undefined. Once we have the critical numbers, we check if these critical numbers are on the domain. Our domain is from -3 to 3, so I check here on the domain. Yes, -2 and 2 are on the domain. So to find the absolute, we substitute all the critical numbers we have, -2, f at 2, and the end points, 3 and -3. We substitute this on the original function. For f of -2, we get -2, we substitute it here, -8 plus 8, which is 24. We get 24 for this one after substituting it on the thing, on the original function. So substitute on the original function, we'll find this to be 24. And then substitute 2, when we substitute 2 here, which will be 8 plus 8 is 16, 16 minus 24, 16 minus 24 is -8. I substitute 3 on the original one, 3, 27, 36, 36, so we have 27 here, 35 minus 36, which is -1, and I substitute -3, which is -27 plus 8, -27 plus 8, which is -19, and then we have 24 here, 24, so I take that one, 24, and I found out to be negative. Okay, so we have -27 plus 8. -27 plus 8, we add that one first, which is -19, and then we have 36, which will be 17, minus 17. Okay, so we have these numbers now. This will help us to find absolute maximum. So the highest point here will be 24, which means absolute maximum is 24. We have it when x equal to -2. So the point is that absolute minimum is the lowest point, which is -17. This is absolute minimum. which is negative 17. It's at x equal to minus 3. Okay, now we have absolute maximum, absolute minimum, so we have to find local maximum and local minimum. To find local maximum, local minimum, we have to have a chart. So we have the factored form here, 3, x minus 2, and x plus 2. So the values which make this equal to 0 are 2 and minus 2. So we take this chart here, and we take the domain, which is, the domain is from negative 3, and then we have negative 2, we have 2, and we have 3. So I take 3, if 3 was negative, it would be dangerous, so, but 3 positive is okay. And the other one is x plus 2, and our derivative is this. Therefore, let's see the conditions of our function, what will happen. So now we have here this. From minus 3 less, we don't take anything, but here this is negative, and we have positive here at 2, and positive here. At x equal to minus 2, it's negative here, and then when x is negative 2, it's 0, and then we have positive, positive, and positive. So our function will be negative times negative is positive, and then negative times positive is negative, and then positive, and then positive. So the behavior of our graph will be fx. So fx here we have positive, so it's increasing here. We have here decreasing, increasing, increasing. So increasing means my graph will look like that, and decreasing means like that. Therefore, we have a parabola here with maximum. Decreasing is this way, increasing is this way. Here we have increase and decrease, so we cannot have local. Local, for a local, there must be a change from positive to negative or negative to positive. Therefore, we say local maximum at x equal to minus 2, local minimum at x equal to 2. And that's it. We found the local maximum, local minimum.